As an introduction to finding oblique asymptotes, I'm going to remind you how to do long division. Now, if I give you a sum as shown on the screen, 86,975 divided by 7, you can see that that is an improper fraction. In other words, the number in the numerator is bigger than the number in the denominator. The number in the denominator is called the divisor, and I can write that outside a division bracket. The number on the top is called the dividend, and that is written inside the division bracket. Now, if I want to do long division, I take my divisor and I see how many times it can go into the first digit on the left of the dividend. 7 can go into 8 one time. If I then times down, I times that part of the quotient times my divisor, and 1 times 7 is 7. Now in the next step, I take the number that I originally had and minus this answer after I had times, and 8 minus 7 is 1. Lastly, I bring down the next digit, and the next digit is 6. Then I start from the beginning again. 7 into 16 goes twice. 2 times 7 is 14. When I minus, I get an answer of 2. Bring down the next digit. 7 goes into 29 4 times. 4 times 7 is 28. 29 minus 28 is 1. Bring down the next digit. 7 into 17 goes twice. 2 times 7 is 14. When I minus, I get a remainder of 3. And bringing down my next digit, I can find that the last number is going to be a 5. 5 times 7 is 35, and in this case I had a 0 remainder. The number at the top is called the quotient, and this is going to give us the equation for our oblique asymptote. Let's see how I can apply this with an algebraic fraction. When I want to use long division, I must remember that I need to show all the terms in reducing degree of x. Now you can see in the numerator, I've just at the moment got x cubed. So that's going to be x cubed plus 0 times x squared plus 0 times x plus 0. In my divisor, I've got x squared plus 1. That means I actually have x squared plus 0 times x and plus 1. And now I'm ready to do my sum. Remember, I said take the divisor and divide it into the first digit of the dividend. Let's do this on the side because some of you get a little bit confused. How many times does x squared go into x cubed? Can you see that I've got 3 x factors at the top, only 2 at the bottom, and so the answer is x. So x squared goes into x cubed x times. Now you'll have noticed that I only used the first number in the term of the divisor. But when I multiply down, I multiply to all of those terms. So I must times x by x squared, by 0 times x, and by 1. So x times x squared gives me x cubed. X times by 0x gives me 0x squared. And x times by 1 gives me x. Now I'm ready to do the step where I'm going to minus. If I minus and my expression is made up of 3 terms, then I must minus all 3 terms. So I'm going to minus all of those, which means that they must all change their sign. X cubed minus x cubed is now 0. Plus 0x squared minus 0x squared is obviously 0. But when I take 0x and I minus x, I get an answer of minus x. X squared cannot go into x without a remainder. So this is in fact the end of my sum. Remember, I told you that the quotient would give you the equation for your oblique asymptote. So the oblique asymptote is going to be y is equal to x. Now, what is this information that I've got at the bottom over here? An oblique asymptote is derived as an application of horizontal asymptotes. For horizontal asymptotes, we took a look to see what was going to happen as x tended towards infinity or negative infinity, which means that actually sometimes I can cross a horizontal asymptote so long as I'm not at the far ends of the graph. In the same way, I can cross an oblique asymptote so long as I'm not near infinity or negative infinity. This remainder over here tells me where I can cross it. As minus x is equal to 0, it means I'm going to be able to cross this oblique asymptote when x is 0. Just so that you can understand this concept, I'm going to show this to you as a graph. Over here is the graph of x cubed divided by x squared plus 1. What I'm going to do now is I'm going to show you the oblique asymptote. Can you see the oblique asymptote means that I'm going to tend towards this line of y equals x as I get closer and closer to negative infinity, and also as I get closer and closer to infinity. But right here in the middle, when x was 0, I actually crossed the asymptote. And this has been shown in the sum that we did using long division.